Today we're going to look at chemicals. What are they? What does that word mean? How can chemicals be put into groups? And we're going to name some examples. So chemicals is the general name given to substances that we use in science. And really we're talking about things that are made up of atoms that are arranged in particular ways or rearranged during chemical and physical changes. And for those of you that are thinking, you'll realize that we're talking about everything. So everything we eat, everything we drink, what our bodies are made of, what we breathe, every time we make a new substance, so plastics, everything you're looking at is made up of atoms and can be described in some way as a chemical. It is helpful to group chemicals with similar properties so that we can simplify our understanding and also make predictions about how a substance, a chemical, will behave. And we can group chemicals based on the type of atoms that are present in the chemical and the way that the chemical reacts. So let's have a go at grouping chemicals. So if we take all chemicals, we can start off by deciding whether they are an element or a compound. And this is to do with the type of atoms present. So if there's only one type of atom, then it's an element, and that might be something really simple like neon, which only contains one type of atom just on its own, or sometimes molecular elements like oxygen, where there are two oxygen atoms joined together going around together as an element, and similarly for chlorine. If there are more than just one type of atom, so two or more types of atom joined together, then it's a compound. And compounds can be split in many different ways, and this is one way. Firstly, we could split them into organic and inorganic compounds. And an organic compound contains the atom of carbon, but it has to be present with hydrogen, and it usually comes from a biological origin. So some examples that I've put down here include the sorts of things you might see on food packets, like fats and proteins, or things that you know are in your body, like DNA. So I've got a symbol there for the sugar glucose. So the molecular formula for glucose is C6H12O6, and you can see carbon is present alongside hydrogen. And we've got an alcohol there, ethanol. You've got carbons with hydrogens and also hydrocarbon fuels such as methane, propane, petrol, those kind of things. So those are organic compounds, and that's one way we could describe a chemical. If it's inorganic, there are many ways that we can describe compounds that are made up of more than one type of atom that don't contain carbon with hydrogen. And one way is to think about how they are joined to each other as atoms. If they are joined covalently, that means they share electrons. If it's a non-metal and a non-metal, they will join together by sharing electrons. And if they are very simple and small, we call them a simple covalent molecule. And the examples there are carbon dioxide and ammonia. And you'll notice carbon dioxide obviously has carbon, but it doesn't have any hydrogen, so it's inorganic. There are some covalent molecules that join and just keep going in a giant lattice. And silicon dioxide is one of those. So silicon and oxygen, they're both non-metals, and they join not just with silicon and two oxygens, but over and over again, more and more silicons, more and more oxygens, until they form thousands of atoms big molecule. That's what you see as the tiny grains of sand, quartz in sand. The other way to split inorganic molecules is to look at how they interact with each other. And we have the categories of acid, base, and salt. So if a substance, a chemical, gives you a pH value, that's the acidity value of less than 7, that means they are releasing hydrogen ions. And they would include things that you have met in the lab, like hydrochloric acid, sulfuric acid, and nitric acid. And you can see in all of those molecular formulas, there is an H, a hydrogen present that can be released to go off and be an acid. A base has a pH more than 7 and neutralizes those acids. So common bases in the labs include things like sodium hydroxide. Now, when you've reacted an acid and a base together, you get a salt. So you have the metal part from the base and the non-metal part from the acid, and they form an association with each other, which is called an ionic interaction. So they're kind of attracted to each other by positives and negatives. And these might include things like sodium chloride and silver nitrate. And you can see there the metal part, sodium, and the non-metal part, chloride. So when we're looking at categorizing chemicals, you can see all the different ways with some examples here. And let's give it a go with something that might be not already on this list. So I've given you three unknowns here: Br2, MgCl2, and SO2. So that's bromine, magnesium chloride, and sulfur dioxide. So pause and see where you would place them. What type of chemical are they? So hopefully what you worked out is that bromine, we start at the top here as a chemical, bromine contains only Br atoms. So that's just one chemical element. So that means it must be an element. So bromine fits here. And it's one of those elements where two things are joined together, but those things are the same atom. Magnesium chloride. You've got a magnesium and chlorine. So that's going to be a compound. Is it organic? It doesn't have any carbon, so it's definitely inorganic. Now we're looking at a metal, that's magnesium, and chlorine, which is a non-metal. Remember, metal plus non-metal, that's a salt. So magnesium chloride is a salt. And the last one there is sulfur dioxide. So sulfur and oxygen, so it must be a compound. Is it organic or inorganic? No carbon present, so it's inorganic. Sulfur is a non-metal. Oxygen is a non-metal. So it must be one of these two. Is it simple or giant? Well, sulfur dioxide just stays as SO2. It doesn't make any massive molecule, so it's a simple covalent molecule. We're going to have a look at some that are a little bit more complicated now. Let's try diamond. So for diamond, we need to know that diamond consists of carbon joined to another carbon, joined to another carbon, joined to another carbon, joined to another carbon. And each of those carbons is also joined to 4 carbons. So this is telling us a few things. It's telling us that it's an element because there's only one type of atom. It's also telling us that it's a giant covalent molecule. So it actually fits in 2 places on our grouping. Lactic acid, you kind of need to know lactic acid's formula. So if I tell you that lactic acid is C3H6O3, then you can make some guesses. It's got lots of elements, so lots of different types of atom, so it's a compound. It has carbons with hydrogen, so it's organic, and that makes sense because lactic acid found in our muscles, found in sour milk, but it's got the word acid in it. So why isn't it an acid down here? Well, it's not inorganic, it's organic. So there's other types of organic molecule that we can further group if we want to, which might include organic acids. So we'll try and keep it simple. We'll just remember these ways of grouping it, but bear in mind that sometimes molecules can surprise you.